name is Magdalena Whelley. I am a rising senior at Rice studying physics. I'm getting a computational physics Bachelor of Science, and I do research in atomic and molecular physics with Tom Killian. This lab focuses on ultra-cold strontium atoms. We work on highly excited quantum states called Rydberg atoms, where the outer valence electron is excited to a really high principal quantum number, which just means that it is very far away from the rest of the atom, which enables really interesting phenomena, and it makes it a very interesting platform to study new physics. This lab has been focusing a lot on how to detect these Rydberg atoms, especially at relatively lower principal quantum numbers than what is typically expected of a Rydberg atom. I've been working on a lot of the detector electronics and the characterization of the detection system to make sure that we understand exactly what's going on in the experimental apparatus, and also a lot of data analysis. Something I'll definitely walk away with after this experience is a much more detail-oriented approach to physics and life in general, honestly, because you have to be so careful about every single factor going into it. Small, tiny thermal effects can bend a beam of light, or someone walking on the ground above can disrupt a chamber of atoms. And when you get data back, you have to know your system so well and know every single factor going into it that you can be able to understand if something goes wrong, what went wrong and what happened, what explains the data that we're getting. Because it's a physical world, we know there's a reason behind every single number that we get. There's no unexplained phenomena, and that really changes your approach to things, because when it's theoretical physics, it's much easier to get to a certain answer, but when experiment doesn't line up with that, there's always a reason why. I do think that any research scientist would be able to agree that learning to deal with the specific type of frustration that comes with not being able to understand the results of your experiment immediately, or not getting the expected result immediately. It's a specific type of motivation working in research fields because of the fact that things go wrong so often. It does definitely teach you to be more persistent, more patient. I think research has been very pivotal for me in reinforcing that these equations are real. They're real things that govern our world. That's really cool, and that's why I love physics so much.